Good morning, students. I am Vijay Kumar, and I am dealing with the BSc 5th semester. That is what the Unit 3, which is nothing but one of the paper, that is solid state physics. In that, we are going to study the magnetic materials. So, in the earlier classes, we have studied regarding the basics about the magnets. So, the magnets. What do you mean by the magnets? We have seen. Along with the types of the magnets we have seen, along with that how the earth behaves as a magnet, and some of the properties of the magnetic fields and properties of the magnets we have seen. And also we have know how the material is going to become the magnetized. That is due to the origin of the magnetism. That is the concept of the origin of the magnetism that we have studied. Especially the origin of magnetism. Here, as I told you, in case of origin of the magnetism, that due to the nuclear spin, that means the atom consists of the nucleus, that nucleus is going to spin on its own axis. Along with that, the spin of the electron. The third point, that is what next is the revolving of electron. Or we can say the orbital motion of electron. Due to these three spins, that is nuclear spin, spin of electron, and the revolving electron. The thing I studied regarding the magnetic materials. That is what do you mean by the magnets we have seen, and types of the magnet we have seen, the properties of the magnets we have seen. Along with that, how the earth is going to behave as a magnet. Even our earth is also behaves as a magnet. Along with that, all the materials are not behave as a magnetic material. Some of the materials which we observe on the earth are the magnetic materials, but not all the materials are magnetic materials. That why it happens like that? Why all materials are not a magnetic materials? That also I have told you why the reason. That is what in the case of the origin of the magnetism, there I have told you. Just I am recalling the things which we have studied in the earlier class. Here, atoms. We have to consider an atom. That atom consists of the several number of electrons. Okay. So, those several number of electrons, if I talk, this is our atom. At the center there is a nucleus. Around the nucleus there is an electron revolving around the nucleus. Okay. That means the atom consists of the nucleus at the center of the atom, and around the nucleus there is an electron which is continuously revolving around the nucleus. Here, how this magnetism is going to arise in the material, that is due to these things. That is what the nucleus, as I am saying, it is not constant, it is rotating on its own axis. That means I can say that is what the nuclear spin. That means inside the atom, the nucleus are spinning on its own axis. That means it is spinning means it has a dipole moment, as I told you in the last class. Not only that, even though the electron, it is revolving around the nucleus, not only revolving around the nucleus, even though it rotates or spin on its own axis. Therefore, I can say the spinning of electron is just a spin of electron taking place. Not only that, again the electron is revolving around the nucleus. That is what the third point I can write. That is orbital motion of electron. But another I can say here that is what the revolving of. That means in the atom these three is happening. That means atom consists of nucleus as well as the electron. Here the nucleus is not going to stay, but it is spinning there. Therefore spinning of the nucleus I can say a nuclear spin. Along with that the spinning of electron. That means the electron is going to spin on its own axis. Along with that the electron not only spin on its own axis, it is revolving, or else I can say that word as a orbital motion of electron or a revolving of the electron. Here, especially in case of the atoms, electrons are present. Here, all the materials are not a magnetic material, but few materials are a magnetic material. That is, Y means whatever the electron is present in the atom, it should be unpaired. This is very important. If the atom, whichever consists of unpaired electrons, those type of materials is behave as a magnetic material. That means it is going to acquire the magnetic property by the material only when it is unpaired. If it is unpaired, it is going to become the having the property that is magnetism property it is going to acquire. If it is paired, if the electrons is paired, in those case of materials, it is non-magnetic. That means it is not going to acquire any magnetic property here. Okay. Therefore, as I told you, in case of the nuclear spin, this may having a weak effect. The nuclear spin, the effect of the nuclear spin is very weak, whereas the spin of electron, it is what unpaired. Just write this please. Unpaired electron required for net magnetic. As I told you, if the atom is having the unpaired electrons, in that case, it is acquiring the requirement of the magnetic moment. If there is a magnetic moment, there is a magnetism in the material. Along with that, there is an orbital motion of electron or a revolving of electron. Here, this effect is strong. This effect is strong. That means the nuclear spin, which it is spinning on its own axis, that effect is very weak in the atom. Along with that, the spin of electron, that means on its own axis, the electron is spinning. In that case, the unpaired electron required for the net magnetic moment. That means the unpaired electron, where it exists in the material, those materials is a magnetic material because it valid for the properties of the magnets. Whereas the orbital motion of electron or the revolving of the electron, this effect is very strong. So with all these things, how that is in moving charges, it means if there is a moving in the charges, microscopically is responsible for magnetism. That is what moving electric charges. You can write the electric charges here. The moving electrical charges microscopically is responsible for the magnetism, and those material is magnetized when it consists of the unpaired electron. If it is paired, those material is not having any magnetic property there. Yes, this is what about the origin origin of the magnetism. And here the resultant magnetic moment from the spin of a single unpaired electron, that what we call the Bohr magneton. That means the single electron which is having the magnetic moment is this one, that is 9.27 in 3 into 10 to the power of minus 24 ampere per meter square. So this is all about the origin of the magnetism. So if anybody asks why now all the materials are not a magnetic materials, that is due to presence of the unpaired electron. Those materials behave as a magnetic material, but if they are paired electron, in that case it is all the non-magnetic material. So this is what the concept of the origin of the magnetism. This is what I am saying. This is all the basics that you should know. So just I am recording the things here. This is about the origin of the magnetism. So today we shall learn, as I told you, the magnetic dipole. What do you mean by the magnetic dipole? Today we shall learn the concept of the magnetic dipole and the magnetic dipole moment. These two concepts we shall learn. First, we shall see what do you mean by the magnetic dipole. If I consider a bar magnet, okay, this is our south and this is our north pole. This is our bar magnet. What do you mean by the magnetic dipole? The name itself suggesting dipole, that means it has a two poles. In a magnet, always it exists in the two poles, that is dipole we call. And in magnets there is no monopole exists. That we have learned the properties of the magnets there. So in case of the bar magnets, we have two poles, that is south and north. And these two poles are separated by a distance, that is what? 2 times. Why it is 2 times I am saying? Because the distance between, this is our origin, that means the center of the magnet, or you call, imagine. So the distance between the end of the south pole to the center of the bar magnet, it is L. Along with this, the origin to again the north pole, it is another L. Therefore, the distance between the two poles is 2L. That means in case of the magnetic dipole, it is having the equivalent magnitude and opposite nature it exists actually. Okay, there is having the equivalent magnitude, that means the magnitude of the magnetic field strength is same. Therefore, if I define this magnetic dipole, how you can define the magnetic dipole? It is so the magnetic dipole. How you can define this magnetic dipole means the magnetic dipole consists of, these are the two poles of equal strength, even though if there is existence of the two poles but having the same strength, okay, and separated by a small distance. That means the distance between these two poles is, as I told you, it is 2. So this is how you can define the magnetic dipole. Here, what do you mean by this portion and what do you mean by this portion? This portion, which we call it as the pole strength, magnetic pole strength, the ends, the two ends of the magnet, which is nothing but the pole strength. That means the maximum strength we observe is at the ends of the magnet. And this is also a pole strength we call. So the distance between the two poles is 2L. 2L is nothing but magnetic length. Magnetic length. Okay. So this is about the magnetic dipole. This we have to define, and what is the distance between the 2L is nothing but the magnetic length we call, and the ends of the magnets we call it as the pole strength here. And where the strength is maximum, at the ends of the bar magnet, the magnetic field strength is more. So this is the magnetic length 2L is actually a vector quantity, and in case of this magnetic dipole, the directions of the field is always from south to north. Okay, it is always moving from south to north. Okay, just keep it in mind.